Today we're beginning the second unit in our course. The unit is called Statistics of One Variable, and so we're just measuring one thing as opposed to two different variables, which we'll do in Unit 3. So starting with the data analysis, what we're going to do is take data and try to make it meaningful and useful by organizing it and displaying it so that we can see trends and we can make conclusions based on the data that we've gathered. So I'm going to show you today the first step in organizing data that you've gathered. Here's an example where a teacher in a grade 12 class has, I guess, 30 students and has asked them all what month of the year they were born in. So there's 30 different answers here. Some of them obviously are repeats because there's 12 months in the year. And looking at this chart and 30 different data values or data answers in this case, it can be a little bit overwhelming and doesn't really give us a picture of whether or not there's a trend. Is there a majority of the class that were born in 1 month? Is there 1 month where nobody was born? All of those kinds of questions are very difficult to answer just looking at the chart. So what we're going to do is we're going to create what's called a frequency table. And just before we do our frequency table, I've inserted a little link here for you, just a screenshot from a website. If you're interested in looking at the birthday problem, it's a really interesting problem. If you've got 30 people in a class and you ask them all when your birthday is, and not just the month like this problem, but the actual day, there's 365 days to choose from, sometimes 366 with a leap year. You would think that the chances of two people in a class of 30 having the exact same birthday would be quite low. But in actual fact, it's about 70%, which is a little bit surprising. And there's lots and lots that's been written about this problem. It has a lot to do with probability, which we'll be studying in the second half of this course. So I thought that some of you might find it interesting. This is the Math is Fun website, and if you just look at the shared birthdays problem, you can read about how they solved that and how they arrived at the 70% chance that two people in the same class would have the same birthday. Try it sometime. I've tried it in some of my classes, and it's really incredible how many times we find people who have exactly the same birthday in a small class, like 25 to 30. So let's move on and do our frequency table. Here's the frequency table that we're going to use, and you can see that someone has already filled in the middle column for us, and this middle column is what we call the tally table. And it's just like you've been doing for years and years, probably going back into elementary school, where you had to count up the number of objects and keep track of that. And so what we did was we used a tick for each one of those objects. So you can see that from the chart, they counted up the number of people who had birthdays in January, and there was 1, 2, 3, 4 of them. So we're going to go over here to the frequency, and we're going to fill in 4 for the total number of people who have birthdays in January. In February, there's only 1 person in this class. In March, there were 2. In April, we had 2. And then filling it in all the way down. June is 3, 2, 4, 6, 2, 3, and 2. So a couple of things about this frequency table. One is that just having done the tally and then the totals in the frequency tells us a lot about our data already, and we haven't really even organized it into anything else such as a bar graph or a histogram or anything like that yet. If we look at our data, we can see that a couple of things stand out. One is that September has 6 birthdays, which is unusually high, and that February has only one, which is unusually low, although there's 2 or 3 months here who have just 2 birthdays. So already we're starting to see some trends in our data, which is great. One of the other things that we will be doing a little bit later on with the frequency table, so we might as well start talking about it now, is doing what's called a cumulative frequency. A cumulative frequency just means that we're going to add up as we go along the totals. Let's see if I can write cumulative in here and spell it correctly. So the cumulative frequency. And we're going to just go down the chart and add as we go. If I'm adding correctly, which doesn't always happen, then it would appear that we have 35 students in our chart. Now, one of the reasons that I wanted to do the cumulative frequency is that whenever you're organizing data like this and transferring information from one chart to another and so on, it's really easy to lose a piece of data. And so a couple of things that I would suggest that you do here is, first of all, if you are just looking at the chart where all the months were listed, as you're counting them, maybe cross them off. So as you go through January, every time you see a January in your chart, then cross it off when you've done your tally. By the end of the counting and by the end of creating your frequency table, hopefully you have everything crossed off. If not, it'll become obvious which one you missed because it's not crossed off yet. Another way to ensure that you got all your data is to look at the total at the bottom, and in this case 35. Go back to your chart and make sure that there were 35 data values there, and that way you know you haven't missed any as well. It doesn't mean that you don't have one in the wrong category, but at least we know we got them all, and that's a good start. The other reason that cumulative frequency is really useful, and we'll be using this again later on in the course, is that sometimes we like to look at life in terms of percent. You guys always want to have your test marks in percent and things like that. We always talk about, the poverty rate is 20% and things like that. So if we want to do percents with our values, it makes it so much easier if we have a total. So for instance, if I wanted to know how many people have birthdays in January as a percentage of the class, I could easily go up here and just take the 4 and divide it by the 35 and multiply it by 100. Now I've got it as a percent, and I can say therefore this percent of people have birthdays in January. So even though we're not being asked to do that yet, it's a really good idea to get in the habit of doing that, because it's a good self-check to make sure that you haven't made any errors when you're organizing your data. And it also makes it a lot easier for us to analyze our data later on. We're going to need all that information anyway.